A week from today will be test 4. I already talked about test 4, which will cover acids, bases, and also organic chemistry. If I didn't say it already, I'll say it now. I hope you all have a happy Thanksgiving. I hope you get everything you want to eat on Thanksgiving dinner, whatever it is. By the way, the best part of the turkey is the part that goes over the fence last. That's the tail. If you know Yiddish, we call that the pupik, also called the tush. Both are Yiddish words, in case you didn't know that. And in my family, my brother-in-law and I love it. And we years ago came to a mutual agreement how to divide it equally, so everybody's happy. That, and the other best part of the turkey is the skin, which my sister knows how to make nice and crunchy and good, real nice. And with all that cholesterol, it's real healthy. Not. I've already talked about test 4. There's an announcement there. What I'd like to do today first is go through the recommended problem set for organic and then go over some important things. And I have something else I'll talk about also. And if you notice, I'm pretty much up to date on my video, so if you want to look at things, instant replay, you can go to YouTube, CHEMI 1105 YouTube. That'll take you there. All right, let's go through this. These are things you should know for test 4 coming up a week from today. All right, first of all, what is a hydrocarbon molecule? That's a molecule with only carbon and hydrogen atoms. Remember, everything up here is in Blackboard, but you can copy it down too. Number 2, what is a saturated hydrocarbon? Well, a hydrocarbon is a molecule with only carbon and hydrogen atoms, and saturated means it has only carbon-carbon single bonds. Next, what's an unsaturated hydrocarbon? Since the hydrocarbon is a molecule with only carbon and hydrogen bonds, when you see the term unsaturated, that means it has at least one carbon-carbon double or triple bond. I tell you, I think I might have mentioned it once or twice or 100 times, who's the greatest organic chemist around, and that's Mother Nature. And Mother Nature never created a triple bond, but organic chemists did. Then, one of the most important things I can teach you now about organic chemistry is how many bonds to carbon. So you can do that on the ambidextrous. Thank you for my assist from my assistant there. Try to get up and do one yourself. No, go for it. But anyways, there's 4 bonds to carbon. Knowing that, next question, how to put in hydrogens in a structure, which is an important skill in organic chemistry when you're drawing structures. And because you know there are 4 bonds to carbon, you look at each carbon, look how many bonds there are, and then the remainder are hydrogen. And if we look at this carbon, there's 1 bond to it, and 4 minus 1, the math is heavy in organic chemistry, is 3 hydrogens. Here, 2 bonds, and 4 minus 2, 2 hydrogens, and that's how you get that. And why don't you try one yourself? Because I should share for the holidays. By the way, for Thanksgiving, never ever give Dr. White as a gift sweet potatoes, because it's the only thing that Thanksgiving, I do not like and never have sweet potatoes. Everybody else in my family loves it, but I never did. And hopefully you'll enjoy the string beans with French fried onion rings on top. That's a classic in our house, string bean casserole. And then the classic desserts, apple pie and French silk pie, and blueberry too. Remember, when you're done, look up and smile. It's not 1 o'clock. High fives. My hearing might be bad, but my peripheral vision is good. I can see back here. If you ever gone like this, check your peripheral vision. All right. Let's do it. All right, how many bonds to carbon? 4. I know there's 1 bond to that carbon. 4 minus 1 is 3. Same thing here, same thing here, same thing here, same thing here. Wow, I sound like a broken record. Any of you ever heard a broken record? Probably not. Anybody ever play a regular record? Probably not. Doing generation gap thing in honor of Thanksgiving. No. All right, let's look at these. How many bonds to carbon? 1, 2, 3, 4. 4 minus 4, 0. Same thing here, count the lines. How many bonds is carbon? 1, 2, 3, 4. 4 minus 4, 0. No hydrates. 2 left to go. 1, 2, 3. 4 minus 3, why 4? Because there's 4 bonds to carbon. And same thing here. And that's how you do it. Now, an important skill, which when you go and learn about naming in organic chemistry, we call that nomenclature, is to count how many carbons are in a molecule or a special part of a molecule. And therefore, I have the question, how many atoms are in the following? And you just count the carbon atoms, because that's the most important. And if you notice, the first one is 6. Now, B, for a ring, every bend in a line is a carbon. Therefore, how many carbons are in this molecule? 1, 2, 3, 4, 5, 6 from the ring. 1, 2, 3, 4, 10, plus 2 more is 12 carbons in this molecule. Now if we look at C, same question. How many carbons are in that molecule? The ring has how many bends? 5. Therefore it's 5 carbons plus, oh, I almost started using nomenclature. This is called the methyl group, this is called isopropyl, will not be on any test or final, but 5 plus 3 plus 2, 10. How did you do this one? How many carbons are in that molecule? This organic chemistry is thirsty one. I think everybody's done. Let's start counting. First of all, we have a ring. How do you know it's a ring? Bend in the lines, and they're connected together. You call this a hexagon, we call that a ring. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 carbons if I counted right. Let's see. 4 plus 2 is 6, plus 1 is 7, plus 6 more is 13. So that would be the answer. By the way, this is called the tertiary butyl group, or T-butyl group. It's time to admit I really am an organic chemist. Dr. White loves T-butyl groups. They've been good to me, I've been good to them. They helped me out in my research, and I'm forever grateful. If we look at D, we just have 6. And by the way, E has 4 carbons. In case you were wondering, how many of you have ever used the nail polish that says ethyl acetate as opposed to acetone? There are 2 types of nail polish. Ooh, I can give you some. This will not be on the test. I got enough time today to do this, because the fun part of organic chemistry, it's in your daily life. If you go to any big box store, Target, Walmart, or anywhere else, and you can see Dr. White forgot to polish his nails this morning. But anyways, you'll forgive me. If you go to the aisle that has all the bottles for nail polish remover, there's 2 types. One contains the chemical acetone. The other contains the chemical ethyl acetate. And until a couple of years ago, most of the aisle was acetone. Because when you used it, if you had any cuticles or cuts, it wouldn't burn your fingers. And that was good. Except about 2-3 years ago, it changed. And a lot of the bottles are now ethyl acetate nail polish remover. How can you tell? Read the label. Either it will say acetone or ethyl acetate. And what caused this change? How many of you are familiar with the nail polish that after you put it on, you put your hand under a light? And you can see I use it every day. But anyways, I learned about this a couple of years ago from my Chem 1212 students, organic chemistry, when I talk about these chemicals. And what I found out was that the newer nail polish that's super durable, this doesn't do a good job taking it off, removing it. This does a much better job. And that's why this made a comeback. And that's why you see more bottles of that on the shelf than the other. And when you take organic chemistry, if you have a good teacher, you'll learn that it's in your life everywhere. And that's the fun part about it. All right, let's look at the following. Circle the functional groups in the following. How can you find a functional group? Simple. Look for what's not carbon, look for what's not hydrogen, and look for what's not a carbon-carbon single bond, because that's where all the fun is and the action, and it is. Now if we look at this molecule, carbon, hydrogen, carbon, oxygen. It's called an ether. You don't have to know that, but I do. And that's a functional group. And over here is an aldehyde. And that's a functional group. And if we go to the next one, we have rings, but rings are not considered a functional group. But here I have an oxygen, a hydrogen, and a carbon. That's called an alcohol. I think a lot of you have heard of alcohols. There are many different types. One is found in, I can teach you some stuff along with. Oh, by the way, I wore this shirt. Am I invisible now? White on white on white. All right. Small little molecule. It's got a functional group. How can you tell? the oxygen with the hydrogen. This is called, this won't be on the test, but I thought I'd teach you some stuff. This is the molecule, first of all, you find in gasoline now to help your engine run better. Next time you go to a gas station, you'll see a label somewhere. This gasoline contains up to 10% ethanol. And this small molecule, and I'm in no way taking a moral stance, this small molecule is responsible, is the molecule in beer, wine, hard spirits, you know, the good stuff, Absolute Vodka, Grey Goose Vodka, Canadian Club, Armoretto, you know, the good stuff. That if you consume too much, which I'm never suggesting, you get imbibed, which is another way of saying drunk. And never drive when you're drunk. That's important. But how this molecule does that to your body, I have no idea. I'm an organic chemist, and that's a different branch of science. I know how to make it, and I know how to react it to make other things. By the way, that molecule reacting with another molecule is used to make your nail polish remover, the ethyl acetate. Let's continue on. What functional groups are in this molecule? Ooh, nitrogen. It's called a quaternary ammonium salt. Nitrogen, that's called an amide. Here I have another functional group, and this is called a ketone. And finally at the bottom, there are two nitrogens. And this is called an amine. This is called an amine. As I said, we're in my home court now when we talk about organic chemistry. My PhD is in synthetic organic chemistry. Synthesis or synthetic is a fancy word for to make. And my training is how to make molecules. Now, R sub T means you've got tallow, which comes from beef fat, which means you have 18 carbons with and without a double bond. And this molecule, for many, many years, until about 8, 10 years ago, and then these two groups were replaced with something cheaper, was the key molecule used in fabric softener. And because of these long R carbon groups, when it's on your cloth, you think, ooh, long R group, it makes it feel softer. And that's how fabric softener works. Now, do I have, ooh, I do. Years ago, I worked for a company that made this, and I was section head of product and process development in North America, and it was an international company. And one of our biggest customers was Lever Brothers. Another one was Procter & Gamble. Lever Brothers is Snuggle, Procter & Gamble is Downy. And having worked with key people at Procter & Gamble, P&G, also I took them out to dinner. That's how you get people like you, get them drunk, and company money. It's true, it happens all the time in the chemical industry, and probably others too. I learned stories. Now, how many of you are familiar with the dryer sheets? First of all, those are the best. They're much better to use for softening your clothes than putting the liquid in your washing machine, because it puts more quaternary ammonium salt, and I'll try and be a good boy, because if you work in quaternary ammonium salts, I have patents in there and I'm a little authority, you call them quats, but I'll try and stay away from slang. And one of the stories I learned was about when they first came out with the dryer sheets for Downy. And they were the first to come out with the dryer sheets. Now, if you work for a large international company, they have a marketing sales group. And the marketing group, if they're good, and they better be or they get fired, because they're not going to help make money, is when they have a new product they're thinking of making, they go out and do surveys and research and find out what kind of market is available for that product, and they come up with estimates like the first year, how much should we expect to sell? And upper management, the CEO and vice presidents, expect that to be accurate. Well, when Snuggle came out, not Snuggle, Downy, the fabric sheets, which is the ones I use, I like it, and turned out sales were half of what was predicted. And upper management wasn't happy, because here you told me I'm supposed to get so many $1 million in sales, and now I have half of that. And after a couple of quarters, management said to marketing sales, find out what's wrong. So they did market surveys, and one of the things I learned from Lever Brother, Unilever, and Procter & Gamble is they both have, and many other companies do also, that they have the most profound respect for the American housewife, because that's a very smart person. And it turned out the original sheets, when they were being sold of Downy, the American housewife figured out, guess what? I can save that sheet and use it for another load. And that's why their sales were half, because they were reusing it. Well, once they found that out, the solution was obvious. Cut back the amount of quaternary ammonium salt on the sheet so you could only use it one time. Their sales doubled, and everybody was happy except the housewife, I'm sure. That reminds me of another, and I can't think of which company this was, but a similar thing. They came out with a new shampoo, and someone had the brilliant idea, how can we increase sales? So they changed the instructions on the back. And they said, after shampooing once, repeat. And now people use twice as much, and their sales went up. Marketing sales, be careful. It's everywhere. All right, let's get into some reactions, because that's where the fun is in organic chemistry. And the key thing is to learn general reactions. And you should know that for this reaction, what's different? This carbon, hydrogen, carbon, carbon, single bonds. Therefore, it's a saturated hydrocarbon. I got lazy and didn't spell the whole word out. Oxygen, you get CO2 and water. And this is propane. By the way, propane is the stuff in the white tank. And here we have propane, oxygen. This is called combustion. I don't ask for the heat because I'm asking for the chemical products. And you get CO2 and water. And remember, organic chemists are lazy. If we don't have to balance a chemical equation, we don't. Most of the time, we don't. And if you notice, next, if we go to B, same thing, saturated hydrocarbon, oxygen. By the way, that has 8 carbons. That's called octane. That's a major component in gasoline. Next time you drive by a gas station, the main product they're selling is a very complex mixture of organic molecules that you use in your car. This is a ring, but it still has only carbon-carbon single bonds and hydrogen. We don't show the hydrogens on a ring. Oxygen, oh, I didn't even show the answer. Sorry about that. I'll do it real quick. The answer for C should be carbon dioxide and water. And why don't you try this one for your fun and enjoyment on this holiday, or Monday before the holiday week. The question is, give the products for the following reaction. By the way, there's only about a little over 30 more shopping days till my birthday. Remember, Dr. White, my all-time favorite gift, I hope somebody gives me, is a bowl of pennies. It's the bowl of pennies. Just pennies. By the way, Avogadro's number 6.02 times 10 to the 23rd. That'd be 100 million piles, and each pile have $1 billion in it. That's just some old pennies. All right, let's do this. This is where I'm inoculating you to the chemistry instructor's favorite trick on a test. Put a big scary molecule. Ooh, big scary molecule. No. You know what to look for? Anything besides carbon, hydrogen? No. Anything besides carbon, carbon, single bonds? No. So this is saturated hydrocarbon. What am I reacting with? Oxygen. And you should know, i.e. that is memorized, saturated hydrocarbon, oxygen, what do you get? Carbon dioxide plus water. What do you get up here? Same thing. And that's how you do it. All right, let's go to another reaction. And if we look at D, the first thing you should be doing when you look at a molecule is look for what's different. What's not a carbon-carbon single bond, 2 lines, double bond. And notice I have arrows. Look there, different. When you see a double bond, what happens? What are you reacting with? Hydrogen and a catalyst. What do? You break one of the bonds, it's called a pi bond, but I won't ask that on a test. And each carbon of the double bond gets a hydrogen. Do you break carbon-carbon single bonds? No, except for combustion. It's extremely rare. And therefore, I start with 4 carbons, I end up with 4 carbons. The only thing I do is break the pi bond and put a hydrogen on each carbon. Same thing here, same thing here. And let me give you another example. And why don't you try this one for your fun and enjoyment? Did you notice there wasn't too much traffic out on the roads today, which was nice? I'll take a walk around the block while you're writing down that molecule. Time flies when you have fun with organic chemistry. All right, I think everybody's done. Let's take a look at this. First thing you should do when you look at an organic molecule in a reaction, what's different? What's not carbon? What's not hydrogen? For this class, what's not a carbon-carbon single bond? And, ooh, look, a double bond. And now you see that, nothing else is going to react. And now this is my functional group. I'm reacting with H2 and a catalyst. The catalyst, which is something that makes the reaction go quicker. And the catalyst can be platinum, palladium, or nickel. And you break one of the double bonds, and each carbon of the double bond gets a hydrogen. Do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5, 6 across. 1, 2, 3, 4, 5, 6 across. On this carbon, I have a carbon. On this carbon, I have 2 carbons. Those are called methyl groups. And which are my 2 carbons? Double bond, these 2, which are these 2. Notice I broke this one of the bonds, and each one gets a hydrogen. And I can fill in the rest of the hydrogens because I know this. And that's how you do it. Now, if you want to make that CH2 and that's CH2, that's fine, but this is easier for you. Yeah. As I've said a number of times, I'm this close to the grader in this class, me, who does the test. All right, let's look at a couple other important things. You should know, because I talked about it, what's tallow? Tallow is beef fat. What's yellow grease or white grease? It's pig's fat. And that's because I'm putting this down, because I worked in this industry for a number of years. And one company I worked at, we would buy tallow and yellow grease, white grease to the tune of about 2 to 3 million pounds a week. And one of the things I would like you leaving my class knowing is how does soap work? Again, one of the things I would like you to leave my class knowing is how does soap work? And the first thing you have to know is what's the structure of all soaps? Nonpolar tail, polar head. Next, what do we use to clean our hands or whatever? Water. But water is polar. What is on our hands we're trying to clean, or your clothes? So far not on my white shirt. Anyways, that's dirt. Dirt is nonpolar. And the important part of the puzzle is like dissolves like. And that means things that are polar are soluble in polar things. Things that are nonpolar are soluble in nonpolar things. You try and mix the two together and they're not soluble. But if you notice, I went to bigger font because it's so important. And now you have your piece of dirt magnified, and the soap, which you're now doing like this, unless you have a different method of washing your hands, and you have the tail, which is nonpolar, is attracted to the dirt, and you have a lot of soap molecules surrounding it, and you should know this is called the micelle, and the micelle now looks to water, polar. And water says to the micelle, do you know molecules can talk? No, they can't. But anyways, it quick says, oh, micelle, you're polar, I'm polar, let's go down the drain together. And they do. And the final thing you should know, leaving my class, how does towels work? Or how many of you have heard the expression, ooh, that cloth or that top or shirt breeze when you're buying something? And that really means it absorbs moisture. I don't know who came up with the term breeze, because, nope, I didn't hear breathing. But anyways, that's lame, remind me never to use that again. On your cotton or other fabrics, you have carbons with hydroxyl group, and that's called cotton is one of them. And it hydrogen bonds to it, and that keeps the water from your skin, takes it off, and removes it to your towel or paper towel. Any questions about organic chemistry? Actually, I want to do this. All right, I've got some time, which is good, and you do too, and I think I should teach you a few important things concerning organic chemistry. How many of you can remember 2005? Few of you, but for those who don't, back in 2005, in the United States, in the New Orleans area, in Louisiana, down there, we had one of the worst hurricanes in the history of the United States. It was called Hurricane Katrina. And it came on shore, it almost wiped out New Orleans, literally. Parts of it were flooded badly. And fortunately, this is my personal opinion, I'll mark it, we had a president who was totally inept, and that was George W. Bush. And he did nothing for a while. And the government agency in charge of helping people at times like this is called FEMA, Federal Emergency Management. I don't know what the authority or whatever it stands for. And unfortunately, the person who Bush had put in charge of FEMA, his only experience was running horse shows, which means he didn't do a good job, and his last name was Brown. Can't remember his first. And I won't go into the details, but one important thing that unfortunately happened, hundreds of thousands of people, their homes were totally destroyed from the hurricane, the floods afterward. And the government had to provide very quick place to live, because we had these hundreds of thousands of people in the New Orleans area, and I forgot what other state right near there they were in need. So they went to trailer manufacturers, mainly in Indiana, said, we need trailers fast, and they made them. And after people were living in those trailers for a while, it wasn't the news that made it nationally until a while. People were getting sick, very sick. Animals were dying, young babies were getting very sick, elderly people very sick. And it turned out there is a very brave lady who found out about what was causing this. That's Becky Gillette. And Becky Gillette found out, and one of these days I've never asked her how she found out exactly, but it turned out that an organic molecule called formaldehyde and this won't be on your test, but it's something important for you to learn for the rest of your life. First of all, molecules can be used wisely or not, and formaldehyde has this structure. It's sometimes written like this, or like this, and this is called formaldehyde. And formaldehyde is a common name. In organic chemistry, we have official names called IUPAC names. Nobody ever uses this. This would be methanol. But anyways, formaldehyde is, when used properly, is safe. When not used properly, will cause serious things, including death and cancer and death. One of the things I want to teach you right now, if you're ever interested in a chemical, any ingredient you see on a label, if it's sold on something in the United States, if it's manufactured in the United States, we have what's known as material safety data sheet. And if you go to any search engine, you put in MSDS, and in this case, you'll see different companies, and Fisher is a reputable company, and this is called Material Safety Data Sheet. And they're standardized by the government. Any chemical that's shipped, manufactured, or used in the United States has to have an MSDS. Has to. And not all of them. And if you notice, there are certain parts of it. First one is identification, but the important thing is the second part. And they have different categories. If you see a category 1 or 2, that's pretty bad. And here, you can see carcinogen, and it attacks certain organs of your body, and especially your lungs and other things, and it's quite severe. And it will attack your liver, kidneys, heart, spleen, your blood. It does serious harm. And what Becky did was, she went to this company, or found a company, that made these little badges that could test how much formaldehyde. And it turned out these trailers had a lot of free formaldehyde in the air. And where was this coming from? The wood. What you don't know about, but I do, is, because I work for a company that made it, if you look at wood like this, or like this, it's not solid wood. It's made up of either particle board, pieces glued together, or in strand board, strands of wood pieced together, glued together, or plywood, like over there, that's probably underneath plywood, and that's sheets of wood glued together, and then they put what's called a veneer so it looks pretty on top. Well, the glue in there is made with formaldehyde, and I worked for the largest company making that kind of glue. I worked in an area making what we call resin, you call glue, for automotive to hold sand together to make car engine molds, to make car engines in a foundry. And it uses formaldehyde. And if you do it right, it's safe. Well, unfortunately, it wasn't with these trailers. They were emitting a lot of formaldehyde. And when I found out in the news about this, and about Becky fighting President Bush and FEMA and the EPA at that time under Bush, were saying publicly, Becky Gillette doesn't know what she's talking about, she's wrong. And they went and tested them and found out, EPA, she wasn't wrong. Now, why am I telling you the story? Because when I first heard about this, I heard about what she was doing. I tracked down her phone number and I called her. I called Becky and I said, look, I'm a PhD organic chemist. I'm a world authority in formaldehyde and its uses. I know what you're trying to do. I'll help you in any way free of charge, which I did. And one of the things she asked me to do was, first of all, just after that, or a while later, finally, we had a new President Obama and a new EPA administrator. And it turns out California, which is ahead of many things, had already found out about this problem with wood. And they issued in their state certain regulations called the CARB regulations. CARB stands for California Air and Resource Authority, to keep formaldehyde low in wood products. And she, Becky and other people were trying to get the country to adopt the CARB California regulations. And she asked me to write to not only the head of the EPA, called the administrator, which I did, and also President Obama. And I know there are other people assisting her who were scientists. I don't know if I think I was the only organic chemist. And I wrote those letters. And our work and others she helped got those laws passed. Now, another thing she asked me to do, and this is an unfortunate thing I learned about our politicians, which I had an inkling, but now I know for true. About the time they were going to have this, it had made national news how bad these trailers were. And Congress, under the Select Committee of Congress, House of Representatives under Henry Waxman, was going to have a meeting, not a meeting, what do you call it, investigation. And part of it was, like we just had with President Trump, they were going to have live, open sessions of Congress to find out about this formaldehyde problem. And that investigation and meetings they were going to have, in the committee meeting, they were going to have on TV the owners of the companies that made these trailers that were making people sick. And Becky asked me as a favor to her, would I call the lead investigator of the Select Committee of Congress and talk to him about formaldehyde? And I did. And for about an hour I talked to him and taught him about the dangers of formaldehyde and everything. Some he knew, a lot he didn't. And finally at the end I asked, can you do a favor for me? And he said, what? Can you ask the congressman, that's Waxman, when the owners are before him in front of his committee, subcommittee or committee, and in front of the TV cameras, ask him one question. Where did they buy their wood? As soon as I said that, within milliseconds, he said, I can't. Immediately I knew he knew what the problem was, and what they were doing for TV cameras was a show. It's called PYA, Protect Your Ass, excuse my language, and let me tell you the story behind this. Because of the hurricane, there was a shortage of lumber in the United States. And to make the trailers, and also to make more money, those companies in Indiana went to China. Now, in the United States, because of OSHA regulations, which are worker safety, when you sell something with formaldehyde, you can't have more than 1/10 of free formaldehyde, unreacted formaldehyde, in a product you sell. If you have more than that, now the company that buys that has to have monitoring, kick in other regulations, that costs money, they don't want to do that. So effectively, that's a regulation that keeps the formaldehyde low in the glue and keeps it low in the wood. Guess what? In China, they don't have that. So the free formaldehyde, what was coming out of the wood, was very high and making people sick. Can I prove that? No. Would I bet money on that? Of course, because I know it's true, and that investigator knew it true. Now, what I do want to teach you is a very important thing. Listen carefully. Because of my involvement with Becky, she asked me to talk to a couple people, and these were people who went out and did house investigations for people who were sick from something in their house, and they tested for various chemicals. So I talked to a couple of them, and the horror stories I heard about due to formaldehyde in wood were terrible. I'll give you an example. One person in California, her client was a person who was a hockey star, and his wife was an airline stewardess, which means they had a lot of money, and they had just spent $50,000 remodeling their kitchen. Turns out the cabinets came from China. Guess what? Formaldehyde. And when they were home, they got sick. When they were on the road, playing sports, or if she was flying, they were fine. And it turns out that's what it was. Same woman told me about how a baby almost died from that, and that's because new mother and father, first child, what did they do? They went out and got all new furniture for their baby in the baby room. Where did that furniture come from? China. What was it emitting? Formaldehyde. And therefore, first of all, I'll tell you, one, if you get or know of anybody who gets any furniture or any wood products from China, have it tested. and I'm going to show you how to test it. Becky found this company where, and if you ever want to know this, email me here, and I'll be more than happy to tell you. And that's this test kit. And what it has is they'll send you a badge. You take it out of the envelope. I've never used it because I don't have anything new like that. And you put it in the room you want to test. You leave it there for 24 hours, put it back in your mailer, ship it to them. They ask you, do you want the report by mail or email? They can do either. And within a couple days, they'll send you a report. Here's the level, it's too high or it's too low. And this is the company that Becky used originally, that originally FEMA and the EPA said wasn't accurate, and then the EPA found out they were accurate. So over the years, I've had students use these, and they had good results. Luckily, they haven't found any formaldehyde. Now, carb rules have been in effect in the United States, but China is still like a third world or Wild West country in certain parts in terms of production and laws concerning safety. Anything real quick. But anyways, about 4 or 5 years ago, maybe less, a friend of mine called and said, did you see last night 60 Minutes? And I said, no. And well, go watch it online. I did. And it had a thing about this company called Lumber Liquidators, which makes and sells wood floors, super cheap. And it turned out that CBS did an undercover study because they were selling product marked in places like Home Depot and others, meets U.S. carb laws. It was made in China, and they sent an undercover investigator to China, to his company, posing as someone who wanted to buy this stuff, but cheap. And the owner of the company, they have a videotape on the show saying, oh, all this market meets the carb laws, it doesn't though. And luckily nobody got sick. When that happened to this school and the other school, I sent out to all faculty and staff,